It's ironic and a little weird, but knowledge doesn't always bring understanding. For example, earlier people thought that the flat Earth rested on 3 whales, standing on a huge turtle. With the advent of telescopes and, moreover, the science of astronomy, it became clear that we live on a planet that has the shape of a geoid. But, as paradoxical as it sounds, a large amount of knowledge brings a large number of questions. If before lightning could be explained by the whim of the god Zeus, now it has been proven that this is a physical phenomenon, resulting from a large static charge in the atmosphere, and a whole series appears. New questions: what influences this phenomenon, how it occurs in others, likewise with the universe, which is around us. Scientists still do not know what it consists of, and develop various theories in this regard. One of the most popular and interesting is the theory of dark matter. This is a special term for a substance that does not participate in electromagnetic influence. Interestingly, because of this, matter is inaccessible to direct observation, which means that there is no direct evidence of its existence. But there are indirect factors indicating the presence of dark matter in space. Scientists have discovered this term in order to explain the problem of hidden mass in the effects of abnormally high rotation speed. Outer regions of galaxies. According to this theory, dark matter occupies about 25% of the entire universe, and in combination with dark energy, this figure reaches 95%. For comparison, ordinary matter, which we are used to seeing every day, occupies only about 5% of the mass. However, these are not the only secrets and amazing discoveries that TM keeps. Features of dark matter. Dark matter is one of the most mysterious and at the same time the most common substances in universe. Yes, scientists cannot see it, but they can study it. We can say that dark matter exists and even draw conclusions about some of its properties by observing how it affects matter in the light that we can observe, especially in large-scale astrophysical environments. But the fact that dark matter has so far eluded direct laboratory detection means that some of its properties remain open question. While it is known that dark matter should be cold in nature, theoretically, any still not discovered particle responsible for dark matter can have any mass. Moreover, it could be created, moving fast or slow or not moving at all, relative to the speed of light. But if dark matter moves fast, its properties will suppress the formation of structure on a small scale, which will result in structures different from what we can observe. In particular, we have 3 lines of observational evidence that limit the temperature. Dark matter, gravitational lensing of quasars, features of absorption of light from distant objects, and tidal energy flows in the vicinity of the Milky Way. All 3 circumstantial evidence. They are talking about the same thing. Dark matter must either be heavy enough or be born slow. In other words, dark matter must have been cold even in its earliest stages, the existence of the universe, and not hot or warm. Dark matter is inert. According to the conclusions, scientists, it should not strongly interact with itself, with light, or with normal matter. Not doubt that if dark matter exists, then in the young universe there was a way to create it. However, whatever this path, these interactions no longer occur and have not occurred in large numbers and for a very long time. Direct detection experiments have not revealed dark matter, limiting its possible mass and cross-section. It does not absorb or blur distant starlight, which means this interaction is limited. It does not annihilate with itself above a certain threshold. Otherwise, at the centers of galaxies, a large and diffuse gamma-ray signal would be visible. In fact, it is 100% corresponds to the absence of interaction through any of the known mechanisms. If we hope to detect dark matter directly, we will have to push our limits even further, and even then there is no guarantee that we will gain additional knowledge. In addition, dark matter effects are predominant in small and smallest galaxies. That's not a lot. paradoxically, but confirmed by observations almost everywhere you pay attention. Scientists, according to the laws of gravity, all forms of matter are treated equally, but other forces, such as nuclear and electromagnetic, act only on normal matter. When in the galaxy, there is a big flash, and a new star is formed, all this radiation just passes through dark matter, but can also collide with and be absorbed by normal matter. This means that if the total mass of the galaxy is small enough, this normal matter can be superseded by intense outbursts during star formation. The smaller the mass of the galaxy, the more the amount of normal matter will be expelled, while all the dark matter will remain. The most striking examples are the dwarf galaxies Segway 1 and Segway 3. These are the neighbors of the Milky Way, contain only a few hundred stars, but have a total of about 600,000 solar masses. Attitude: dark matter to the mass of normal matter here is approximately 1,000 ohm, as opposed to 5.1 in most large-scale structures. Dark matter causes gravitational effects in places where there is no normal matter. This is one of the most compelling evidence that dark matter cannot just be normal matter. When two groups or clusters of galaxies collide, intergalactic gas and plasma collide and heat up, emitting X-rays, radiation, but the signal from the mass, obtained as a result of gravitational lensing, shows that most of the mass is elsewhere. The main conclusion is that some new form of matter, dark matter, must make up most of the mass of the universe. Secrets of dark matter. Despite the presence of certain knowledge about dark matter, the secrets of this substance are much greater, and no matter how scientists try, until there is still a huge number of intriguing secrets. For example, we do not know which particles are responsible for dark matter, and even if it's a particle at all, we only know that dark matter exists, that it does not interact with itself, normal matter, or radiation, and that she is cold. But we do not know what properties it actually has. Dark matter may be any one, because all our efforts to directly detect a particle or field of dark matter are not, to which they did not lead. We see its astrophysical effects indirectly, and this is obvious evidence. But real particles have not yet been detected. Dark matter can be homogeneous or heterogeneous. This raises a number of interesting questions. For example, are there dark atoms, dark molecules, or even larger structures composed of exclusively from dark matter? Perhaps there is a whole dark universe, perhaps even including some kind of obscure periodic table made up of several different types of dark particles that interact with each other, but according to its physical laws. At the moment, scientists have already managed to obtain certain knowledge and systematize them. 1. Dark matter is everywhere around us. This is the name we have already given to an unknown mass in the universe, which remains invisible, and there is a lot of it. Studies show that about 70% of the universe is made up of dark energy, while the remaining 25% is made up of a mysterious substance known like dark matter. We don't see it, we don't understand it, but we know it's out there somewhere. 2. She is completely invisible. Dark matter is really hard to study, because we don't have a chance to see it. This strange substance does not interact with light, therefore completely invisible. But how do we know that it exists? Everything is simple because the dark matter indirectly affects the universe around us, creating gravitational and other anomalies. 3. Dark matter binds galaxies together. Yes, dark matter cannot be seen, but it can be felt because of its powerful impact on the cosmos. Dark matter exerts gravitational force, which means that it attracts other matter to itself. Meanwhile, there are so many that the gravitational force is enough to hold entire galaxies together, like our Milky Way. This is why dark matter is often compared to a giant web, unifying galaxy in place. 4. It distorts the appearance of space. We can also see the effects of dark matter just by looking at the sky. When astronomers, distant galaxies are observed, They often appear elongated and have a strange shape. This effect, known as gravitational lensing, and is caused by the gravitational force of dark matter. The force is so great that it physically bends light around galaxies, distorting their appearance. 5. Scientists have created maps of dark matter. Scientists have been able to put together maps of the cosmos, pointing out where they think dark matter is hiding. Studying relic radiation, left over from the Big Bang, scientists can identify regions in space where there is more radiation, and the more radiation, the more matter. In this way, we can identify hot spots where higher levels of dark matter. 6. We don't know what dark matter is made of. Most scientists believe that dark matter is some kind of unique particle. We already know about photons, electrons, quarks, and many other particles, but there may be many others waiting. Of his discovery, one or more of these unidentified particles may be responsible for effects such as gravitational lensing and webs that we associate with dark matter. 7. Dark matter may not exist. It's funny, but dark matter may be undiscovered, particle or nothing at all. Some scientists believe that the effects we associate with dark matter are actually caused by gravity. Perhaps our existing the theory of gravity is wrong, and the effects we attribute to dark matter may simply be a quirk of gravity that we don't yet understand. 8. Spaceships hunt signs. So, dark matter a particle or a consequence of gravity? We don't know yet, and more research is needed before any theory can be proven true or false. If dark matter particles exist, then they must collide with each other from time to time. With a friend, an interaction that produces radiation, and so the spaceships were equipped with advanced detectors to look for signs of this radiation. Appeared some interesting results, but the search for hard evidence is still ongoing. 9. In some countries, dark matter laboratories are hidden deep underground. If ever irrefutable evidence of the existence of dark matter will be found, they will show up as very small effects. It's interesting that in order to detect these tiny signals, scientists have created dark matter laboratories deep underground, away from overwhelming background noise. For example, in the UK there is Bowlby Underground Lab, dark matter lab in North Yorkshire, located at a depth of more than 1,000 meters below the surface of the Earth. And other similar objects exist all over the world, from Canada to Australia. 10. We are getting closer to the truth about dark matter. When it comes to dark matter, there's still a lot we don't know, and some of the mysteries may never be unraveled. But as technology advances, we are getting closer to the truth. Dark matter may be complex, elusive, and mysterious, but scientists around the world will continue to hunt. And what they discover may eventually change our very understanding of the cosmos.